everyone, welcome to Lectures by Aparna. Today we will see what an idempotent matrix means. Consider a 2 by 2 matrix A. A is equal to 4 minus 1, 12 minus 3. Now we have to find A into A, that is equal to A square. A into A is A square, that is 4 minus 1, 12 minus 3 multiplied with itself. 4 minus 1, 12 minus 3. This is a 2 by 2 matrix. This is also a 2 by 2 matrix. So the result you get will also be a 2 by 2 matrix. Now 4 into 4 is 16 plus minus 1 into 12 is minus 12. Next is 4 into minus 1, minus 4, minus 1 into minus 3 is 3. Next is 12 into 4, 48 plus minus 3 into 12, that is minus 36. Next is 12 into minus 1, minus 12 plus minus 3 into minus 3, 9. So you get 16 minus 12 is 4, minus 4 plus 3 is minus 1, 48 minus 36 is 12, minus 12 plus 9 is minus 3. See, this matrix is the same as this matrix A. That is, you got A square is equal to A. A matrix that satisfies this condition is called an idempotent matrix. That is, when you multiply a matrix with itself, if you get the same matrix A, then such a matrix is called an idempotent matrix. So today let's discuss about Hermitian matrix. What is a Hermitian matrix? For Hermitian matrix, it should satisfy the condition A conjugate is equal to A transpose. Okay, so let's see a matrix. For example, A is equal to 4, 1 minus I, 7, 1 plus I, 6 minus I, 7, I and 5. Okay, this is the given matrix A. Now what is A conjugate of this matrix? 4, we can write it like that. 1 minus I, 1 minus I conjugate will be equal to 1 plus I. Okay, so we can write 1 plus I here. 7 conjugate is 7 only. So for a complex number, we have to make its conjugate form. Okay, so 1 minus I will become 1 plus I, and 1 plus I conjugate is 1 minus I. 6 we can write it like that only. Minus I will become plus I. 7 we can write it like that. I will be minus I, and 5 we can write it like that only. Okay, and now we have to find transpose of a matrix, A transpose. What is the transpose of this A? We have to interchange the rows and columns. So this column we will make it a row. Okay, so now this column we have to write it as a row. 4, 1 plus I, 7. Then this column we have to write it as next row, 1 minus I, 6 I, and this column we have to write it as third row, 7 minus I and 5. Now compare these two. We will find that A conjugate is equal to A transpose. So any matrix that satisfies this condition is said to be a Hermitian matrix, and therefore the given matrix A is Hermitian. Today we will discuss about Skew-Hermitian matrix. So Skew-Hermitian matrix is a matrix that satisfies the following condition. So let A be a square matrix. Let A be a square matrix, and it is said to be Skew-Hermitian if it satisfies the condition A conjugate whole transpose is equal to minus A. So this is the condition that is to be satisfied to be skew-Hermitian. So let's take an example. Let matrix A be equal to 3i, 2 plus I, minus 2 plus I and minus I. So this is a 2 by 2 matrix. We have to find the conjugate, A conjugate first. So I am writing A conjugate is equal to, I have to write the conjugate of each element. So for first element the conjugate will be minus 3i. This one it will be 2 minus I. This one minus 2 minus I. This one I. That is, you have to change the sign of the imaginary part. Only the imaginary part sign should be changed. The next step is to find the transpose of this conjugate matrix. So A conjugate whole transpose. That is equal to, so this column will become the row, first row. So minus 3i minus 2 minus I. Next, this column will become the next row. So 2 minus I. Now I have to find this RHS, which is minus A. Minus A, let this be equation 1. Minus A is equal to, that is, I have to multiply each element in matrix A with minus 1. So minus 3i, minus 2 minus I, 2 minus I and I. Let this be equation 2. Now comparing equations 1 and 2, we can find that these two matrices are the same. That is minus 3i, minus 2 minus I, 2 minus I and I. That means 1 is equal to 2 or LHS is equal to RHS. Therefore, this matrix A is skew-Hermitian since it satisfies this condition. This condition is satisfied. Therefore, A is skew-Hermitian. So this is the condition to be satisfied to be skew-Hermitian matrix. Today we will discuss about unitary matrix. So a matrix is said to be unitary if it satisfies the condition. Let A be a matrix. A be a square matrix. So it has to satisfy the condition A conjugate whole transpose is equal to A inverse to be unitary. So this is a condition that should be satisfied by a matrix if it has to be unitary matrix. For example, I am considering a matrix A is equal to I by 2, root 3 by 2, root 3 by 2, I by 2. So this is a 2 by 2 square matrix. Now I have to find A conjugate. A conjugate is equal to, so writing the conjugate I have to change the sign of the imaginary part. So this will be minus I by 2. This is a real term, so it will be root 3 by 2. This will be root 3 by 2. This will be minus I by 2. Next I have to find the transpose of this conjugate matrix. So A conjugate whole transpose is equal to, so this column will become the first row. So minus I by 2, root 3 by 2. This column will become the next row. So it will be root 3 by 2 minus I by 2. Let this be equation 1. Next I have to find A inverse. So to find A inverse of a 2 by 2 matrix, square matrix, there is an easy way. If A is A, B, C, D, then A inverse will be equal to 1 by AD minus BC. This is mod A, modulus of A, this term, into the matrix DA. That is, interchange these two elements. This element will become the element here and this A will come here. And then reverse the sign of these two terms. So it will be minus B minus C. This is adjoint A. This is adjoint A, matrix adjoint A. So A inverse is equal to adjoint A by mod A. So here we can find the A inverse of this A. So finding the A inverse, is equal to 1 by AD minus BC. So AD is I square by 2 into, I square by 2 minus, these two terms you have to multiply. So that is 3 by 4. So this is the term AD minus BC, which is I square by 4. I square by 4 minus 3 by 4 into the matrix. You have to interchange these two elements. So this I by 2 will come here, this I by 2 will come here. It will not make much difference in this case. And you have to change the sign of B and C. So this is the element B. So it will be minus root 3 by 2. This will be minus root 3 by 2. So this is an easy method to find the inverse of a 2 by 2 matrix. So therefore you get 1 by I square is minus 1 by 4 minus 3 by 4 into this matrix I by 2 minus root 3 by 2 minus root 3 by 2 and I by 2. Therefore A inverse will be equal to, A inverse is equal to 1 by minus 1 minus 3 minus 4 by 4. So this can be written as minus 1. 1 by minus 1 is minus 1. Therefore minus 1 into the matrix I by 2 minus root 3 by 2 minus root 3 by 2 and I by 2. Therefore multiply this 1 in each term, it will be minus I by 2 root 3 by 2 root 3 by 2 and minus I by 2. Let this be equation 2. Now comparing equation 1 and 2, we can find that these two matrices are the same, that is minus I by 2 root 3 by 2 root 3 by 2 and minus I by 2. Therefore the condition A conjugate transpose equal to this A inverse. A inverse is satisfied. Therefore this matrix is a unitary matrix and hence this matrix is unitary. If this video has helped you, please do subscribe to my channel. Thank you.